We all know water as H2O, a small and simple molecule. However, water is a much more complicated substance than that. You may read or listen to this lecture that we is given on YouTube, given by Professor Pollack at the University of Washington, that gives you insight into many different aspects of water and also the many things that we still don't know. But for this course, let's focus on some water quality issues that I've put together in this lecture. First of all, okay, it's organized here as a, that's what we're going through. Just what is water? How do we analyze it in terms of drinking water and wastewater? So first of all, water, H2O, it's since it's a dipole with hydrogen bindings, it also turns out to connect with other water molecules, and the actual size of a typical water molecule, if you look at it that way, is more H100O50, and that makes a difference. Also, what is maybe the most important is that water is the most universal solvent around. It can dissolve salts and organic molecules and so forth. Also, because of that, it is never clean. It's never completely pure in nature or even in the lab. So then we need to look at what is in the water, and also often we have to remove things that are in the water, and that's why we have water treatment and environmental engineering. Gases can be solved. There can be particles, organics, and inorganic matter. To then analyze and describe water quality, we have a few parameters such as pH, actually saying something about H plus concentration, but it has implications for most other parameters in the water. So that's something we'll get back to in the course, and you'll meet in many connections. Conductivity, the water's ability to transport electrons or electricity. It is not because we want to do that, but it can give us an idea indirectly of how many ions are in the water. Similarly, how dirty is the water? Well, since there are so many things that can be in there, we need some way of just saying, well, it's turbid, it's dirty, and this is turbidity. Another parameter that is well defined in terms of how to measure it, but not in terms of what you actually have in the water. TOC, total organic carbon, is another way to measure how much organic pollution is in the water. Then we have hardness, describes how much calcium, magnesium, iron is in the water. And we have alkalinity, which is another of these general quality parameters that is very useful. We often try to adjust it in the drinking water. It may influence to a large extent how biological processes are running in wastewater treatment. Okay, then, so those are some general ideas. Now let's go into and see what are we concerned with when it comes to drinking water. Well, the main issue when it comes to drinking water is living organisms. We don't want to get infected by organisms that can cause disease. However, it can be very difficult to find these bacteria. So therefore we have also something we call indicator organisms. For instance, E. coli. Not necessarily dangerous. Well, it can be, but not necessarily. But if we find E. coli that likes to be in human bodies, like warm environments, then there's likely to be fecal contamination. There could be sewage coming in, or there could be animals around the water source. So then there is reason to believe there could also be other and more dangerous organisms. That's why it's called indicator organism. Now, really dangerous organisms that are often a problem is Salmonella. Okay, we have cholera, which is not a big problem in our parts of the world anymore, but it's still alive and killing people in tropical areas. It's not only bacteria that can cause disease, fungus, protozoa, worms, and virus. Now, whether that's considered living organism, that depends on how you define it, but they can definitely be dangerous to us. There are also inorganic matter in drinking water, and some of it we want, and if it's too much, we don't want it. So we may have to treat the raw water before we use it as drinking water. There can be some components that we actually get supplied through the drinking water that can be good for us. So it will have a positive effect if there is more. Calcium could be such an example, but also other chemicals, others that, well, some chemicals will, at some level, actually become toxic. Calcium is not an example of that. Some type of heavy metals could be an example. So therefore, when we treat drinking water, we try to end up with a concentration that is optimal, or we look for a drinking water source that is already optimal. Typically, many trace elements can be essential for growth of us and other living organisms. And if we don't get enough, it can cause health problems. But in general, these are not the sources of drinking water is not the source of trace elements. We get that mainly through our food. So generally, we try to stay low on most components. Okay, I mentioned heavy metals already, which we generally try to remove because they have no positive known biological function. Then we talk about acceptable daily intake. And then we look at some safety factor and we estimate how much we can drink or eat. And you see this is related to our size. In other words, children are more exposed, or it's more important to treat the drinking water well in terms of small humans than adults. Generally, we don't do these calculations because they're already done and there are made some standards for how drinking water should be, like World Health Organization, and also each country has their own standards, which are usually the same as the World Health Organization. Well, radioactive pollution, generally also we try to get rid of it. But it is many places a problem because especially if we use groundwater as our raw water source. Then we have organic toxins in drinking water, certainly things that we want to get rid of, but they may be there that can come to our drinking water source through acid rain and other pollution sources. So we generally try to get rid of them, and we have techniques to do that. There is also this issue, though, that chloroform can be produced in our drinking water plant. When we chlorinate the drinking water to get rid of living organisms, we may produce some chlorinated hydrocarbons that can be carcinogenic. An argument why we should use other sterilization techniques than chlorination. However, what we know is that if we treat the water well before we chlorinate, so there is very little organic matter in the drinking water when we come to chlorination, we also don't generate much carcinogenic chemicals. So there are trade-offs. Chlorination has saved many lives, but it could also be the cause of some cancer cases. So this is a balance between different techniques, something that will be discussed further under drinking water treatment. When it comes to drinking water, we also have this what we call secondary standards. It may be safe, maybe free of dangerous components and free of dangerous organisms, but it may have some color or it may smell in such a way that the appearance is not good. And we don't want that. We want our drinking water to look good, smell good, feel good. And generally it does when treatment is appropriate, such as here in Porsgrunn. We will visit the drinking water treatment plant to look at all the treatment steps and see how we get very nice, safe drinking water according to these standards and parameters we just discussed. Okay, then comes wastewater. What is wastewater? That's the first question. Well, it can come from industries, and it can be full of nasty stuff. And if so, it should be treated at the source. However, when we move many industries discharge their wastewater to the domestic wastewater and the pipes and then to the domestic wastewater treatment plant. So this is an issue that where some of these matters that we don't really want actually end up at the domestic wastewater treatment plant. But there is a development where more and more of the industrial wastewater is treated locally. Domestic wastewater is typically what comes from our houses, but also, as mentioned, from some other sources, from hotels and from small-scale industry, food processing, maybe hospitals, and so on. And it contains mainly organic matter, but also sometimes what we can call garbage. People put things in their toilets they shouldn't, but they do. So we need techniques to remove that at the wastewater treatment plant. There are also nutrients, phosphorus, nitrogen, that can be a problem if it's not removed and goes into the recipient, the fjord or the river or lake. Nutrients are also important because they're fertilizers. So more and more when we treat domestic wastewater, we do it in such a way that we actually capture these to recycle them as fertilizers. Then we have new components such as hormones and hormone imitators and toxins, and we get more and more of these. This is a troublesome issue because there are so many chemicals that are used in every home. Also because people use more and more medication, and some of this ends up in the domestic wastewater. So we're talking about priority chemicals. We don't really necessarily know all the consequences. What we know, they're not good for the environment, so we're looking at ways of removing and treating these also. again, we have parameters to characterize the water quality. We have a long list. We have something called BOD, biochemical oxygen demand. It says something about how, if we break down the organic matter in the wastewater, how much oxygen is required for the microorganisms to do it. Now, if we, instead of using microorganisms, we do complete chemical degradation of the organics, then we end up with the value of chemical oxygen demand. We use both of these quite a lot in the lab. Then we have TOC, organic carbon, not used so much anymore, but it says something about, again, how much organic matter is there in terms of the carbon, which is always part of organic matter. And then we have something called soluble organic carbon, which is the part of TOC that is not particulate, that is dissolved. We also measure total solids, total suspended solids, volatile solids, volatile suspended solids. We'll go through these later in this course to see how we measure them and what they actually mean and how we use these types of numbers. pH, whether the water is acidic or basic, and what implications come from that. We'll look into that definition also. By the way, these are all very well explained and described in the book. They can also be oil and fat, which we may or may not have to remove. Generally, we need to remove almost all of it, and there are different techniques. We generally try to remove them before we remove everything else. Maybe together with sand. So sand trap, fat oil trap can be one process step. And then we have the nutrients, nitrogen, phosphorus, that can cause eutrophication of the recipient water, and which we also want to recycle as nutrients. So we need to measure these. This priority pollutants is really quite a new term in our field, but these pollutants may or may not be detected here, but they represent a hazard to the environment or to us. So there are 10 main groups for this, also described in the book. We may also measure the quality of wastewater by something called ecotoxicology, by exposing, for instance, microorganisms to the wastewater and see how many organisms will die, how many will survive based on the dosage. We may also have to look at bioaccumulation, which we will get back to when we look into the ecosystem part. Some of these things that are not broken down, they may accumulate through the food chain, so that once we get to eat some fish or something, it can have high concentration of something that we really don't want to get into our body, such as pesticides. And then we need to look at how degradable are these toxic components. Maybe we can degrade them in the treatment plant. Often we can, depending on the techniques, but it can also be very expensive. When it comes to the toxicity test, we have something called LC50. 50% survival is kind of what we say. So how much of the toxicity will give 50% survival or death of the test organism. Okay, so that was a brief introduction to water and water quality. Thank you.